Okay, now we're going to do a walkthrough for Lab 11. In Lab 11, we are going to do some analysis of categorical data. I'm going to have you do an actual goodness of fit experiment using M&Ms, and then I'm going to have you walk through hand calculations for another goodness of fit experiment and a test for independence. So you will use calculations like we did in the examples videos for 12.1 and 12.2. For the interactive part of the lab, I would like you to buy a standard size bag of M&Ms and open them up and count each one and put those values in the observed column. Total up the total number of M&Ms that were in the bag and use these percentages to help you fill out the expected column, and then just fill out the rest of the table as what I've indicated. And this gray box down here will then end up being your chi-squared goodness of fit test statistic. There are 6 categories, so there are n-1, which is 5 degrees of freedom. I would like you to try to look at the chi-squared table and tell me what your critical value is at the 0.05 level and whether or not we think that this distribution is accurate for the distribution of M&Ms. The other 2 problems are just hand calculation problems. One is a goodness of fit problem. The other is a test of independence, leading you through the calculations as before. In both of them, I also give information on how to use StatCrunch so that you can verify the answers that you've put in here. For an exam, you should be prepared to know how to find the expected value here. You should also know how you could find the contribution of chi-squared, so the value that goes in this column. In a similar fashion, for test for independence, you should know how to find the expected count for a cell and the contribution it might make to chi-squared. With that said, I will not give you a problem that is as long as the ones that I'm having you do in lab. I will not expect you to fill out an entire table like this on an exam. I would most likely just ask for you to either give me the expected count or the contribution to chi-squared, which would be this expression. Or similarly down here, I would ask you to give me an expected count or some contribution to the chi-squared statistic. Additionally, you should be able to figure out the degrees of freedom based off of if it's test for independence or goodness of fit, and how you could use that information to come up with critical values from the chi-squared table. So that concludes our walkthrough of Lab 11.